Hello everyone, welcome to Business School 101. In previous videos, we explored many useful statistical indicators, such as mean, median, and mode, that offer a quick snapshot of your dataset. But as any data analyst knows, numbers alone don't always tell the whole story. To truly understand the data, you need to go beyond and look at how values are spread out. That's where data distributions come into play. So what exactly is data distribution? Why is understanding it essential? What are the most common types of data distributions, and how do they show up in the real world? In this video, I will discuss these questions with you. Section 1. What is data distribution? At its core, data distribution refers to how values in a dataset are spread out. Some values might appear frequently, while others show up only once. Understanding these patterns helps us interpret what's typical, what's unusual, and where we might want to investigate further. Imagine you're analyzing a company's email sign-up sources, TV ads, social media, newsletters. You can visualize this using a bar chart, where the height of each bar represents how often a particular category appears. If newsletter sign-ups appear 4 times and TV only twice, the newsletter bar will be twice as tall. Sorting these bars from highest to lowest frequency makes it easy to identify top-performing channels. Section 2. Binning and histograms for numerical data. Numerical data doesn't come in neat categories, but we can group similar values together using a method called binning. Think of bins like buckets. For instance, if you're analyzing customer ages, you might create bins for 0 to 10, 11 to 20, 21 to 30, and so on. Then, you count how many data points fall into each bucket. Next, turn those bins into a bar chart, and now you've got a histogram, one of the most useful tools in data analysis. The height of each bar tells you how many observations fall into that range. It's perfect for spotting patterns, outliers, and variability in your data. Section 3. 4 types of data distributions. Let's take a closer look at 4 of the most common data distributions in the real business world. Number 1. Normal distribution, bell curve. The normal distribution is arguably the most famous and widely used. It's symmetrical, bell-shaped, and centered around the mean. The values taper off evenly on both sides, with most data points concentrated near the average. In a normal distribution, the mean, median, and mode are all equal and lie at the center of the curve. For example, imagine a company tracking employee performance scores on a 100-point scale. If the performance data follows a normal distribution, most employees score near the middle, like 70 to 80 points, while fewer score extremely low or extremely high. This allows HR to identify outliers and focus on performance improvement plans or top talent retention. Many statistical methods, like hypothesis testing and confidence intervals, assume data is normally distributed. Recognizing a normal distribution allows you to apply these tools appropriately. Number 2. Bimodal distribution. A bimodal distribution has 2 distinct peaks or modes, indicating 2 groups within the dataset. This shape often suggests that the population being studied contains 2 subgroups with different behaviors or characteristics. For example, suppose you're analyzing website traffic during a 24-hour day. A bimodal distribution might show one traffic peak in the morning and another in the evening, likely reflecting behavior from 2 user groups, one checking the site during business hours and another browsing after work. Bimodal patterns suggest that different segments or behaviors exist within your data. This insight can lead to audience segmentation, personalized marketing strategies, or targeted customer service approaches. Number 3. Log-normal distribution. In a log-normal distribution, the data is positively skewed, like long tail to the right. The distribution starts with a high peak on the left and gradually declines, with most values on the lower end and a few large outliers stretching the curve. For example, consider analyzing product prices across an e-commerce platform. Most items may be priced between $10 and $50, but luxury goods like designer handbags or high-end electronics might cost $1,000 or more. These outliers create a long right tail. Log-normal distributions often appear in business and finance, especially where multiplicative factors are at play, such as compound interest or growth rates. Recognizing this distribution helps analysts focus on managing outliers and understanding pricing strategy impacts. Number 4. Uniform distribution. The uniform distribution is flat, meaning all outcomes have the same frequency. There are no peaks or valleys. Every value in the range is equally likely to occur. For example, imagine a company running a promotional giveaway where each participant spins a digital wheel that gives a random discount, 5%, 10%, 15%, 20%. If the wheel is fair, the discount outcomes would follow a uniform distribution, with each having an equal chance of being selected. Uniform distributions are rare in the real world but important in simulations, randomized trials, or controlled experiments where fairness and equal probability are necessary. Section 4. Why data distributions matter in business. Understanding data distribution is critical in business for the following reasons. Number 1. Improves forecasting accuracy. Knowing the shape of your data distribution helps in selecting the right models and setting realistic expectations. For example, if your sales follow a normal distribution, you can expect most months to fall near the average. But if your revenue has a long tail, as in a log-normal distribution, a few high-performing months might skew the average, making forecasts overly optimistic if not properly accounted for. Number 2. Reveals outliers and anomalies. Data distribution helps detect outliers, which refer values that fall far from the norm. In finance, a sudden spike in spending might indicate fraud. In HR, an unusually low employee satisfaction score could signal a deeper issue. By visualizing the distribution, businesses can spot these red flags early and respond accordingly. Number 3. Supports better resource allocation. Understanding where the bulk of your data lies helps businesses allocate resources efficiently. For instance, if customer service wait times follow an exponential distribution, with most calls happening in short bursts, staffing can be adjusted to match the peak periods and reduce costs during lulls. Number 4. Informs strategy and risk management. Different distributions imply different risks. A uniform distribution may suggest consistent outcomes, but a skewed or bimodal one might indicate segmentation or volatility. For example, a bimodal traffic pattern on an e-commerce site could reveal two distinct user groups, prompting tailored marketing strategies. Section 5. Summary. In this video, we've explored the basics of data distribution, from bar charts to histograms and from bell curves to skewed patterns. These visualizations do more than make data pretty, they reveal trends, outliers, and opportunities. As we continue in this series, we'll see how these insights lay the foundation for modeling, forecasting, and interpreting real-world business data. That's all for today's topic. If you found this video helpful, don't forget to give it a thumbs up, share your thoughts in the comments, and subscribe to our channel for more insights on business analytics. Thanks for watching, and I'll see you next time.